This is pretty crazy, guys. I just tried this out for the first time. I had this idea. I'm combining different systems. But look at that. I don't know if you see that, but that is crazy. Whoa. We've reached some sort of a harmonic resonance. It changed from pulsing to more stable. And this Bendini motor is from K Energy. These batteries are 12 volts. I'll show you the spec on them there. So that's EXP 1270 is what you type in to order it. You can find it on Amazon. This is a MEG cell reproduction. So I just noticed that this other bulb started turning on and was like it's going into a feedback loop of even more energy. So I had to turn up this resistance because this is now decoupled. But yeah, I had to decouple it because I was getting scared here. I'm gonna turn it off because um, this MOSFET's ice cold. That's amazing. This battery's cold. This battery's cold. Wow, listen to that. Usually it does not take this long to spool down. So something is definitely going on here. This is a cool effect. Okay, so back to this meg cell. Sorry, I got distracted there, but I noticed that off camera and I wanted to not get too caught up in the moment here. But this meg cell, or this is on TimTron's channel, and this is labeled something like the best meg cell ever or something like that. And I reproduced it the best I could with what I had, which is very similar, not quite the same. The only difference is the core is a little bit different and the magnets on the outside are different, but the rest is the same. However, I've coupled it to different systems here, as you can see, and we'll get to that. So basically, what I've done is I've taken these magnetron microwave magnets. As you can see, they're broken in half. That's not a complete magnet. Stack those together. I figured out their polarity by sticking a wire in here so it would hold it, and then I just held the wire on the very tip so that it'd spin in my hand, like on the metal part. And then I knew, because I knew which way was north, that I know which way this is facing. So I have this facing so it helps couple with the magnetic field of the earth even. And then further earth coupling using Nikola Tesla's ideas is with this, I believe it's either quartz or tromlodite, something like that. It's probably quartz. But you can see it's got some like marks in there, like energy's been like really flowing through there. And the wire wraps around it, goes to this rod which just touches on this concrete here, because I got this amp meter I can use. It goes up to 1 amp, which is a decent amount. And so I connected it right here on this side of the diode and started it. So let's clarify this wiring real quick so you just know what's going on, so because it looks like a jumble, right? This is your common negative on your right side here with this white line and with this lower line, so that negative goes to these secondary coils. So it goes this coil first, and then it goes to this coil, and then it goes to this coil, and then this one. Now, as you see, the end of this wire isn't connected to anything. So it's just a floating one wire ground, technically, that just builds capacitance. and I just have these in parallel with the battery, so it just stores extra energy. So what I did here is I built a cascade, an energy cascade of higher to lower capacitance. All right, I just got some examples. So we got 3300 microfarad 25 volt as the first one, and then the next biggest one is 2200 microfarad 25 volt. The next one, well, it's not coming out very good, but I can tell you that it's 1000 microfarad and it's at 16 volt. And then we have a 100 microfarad 25 volt, and then we have these three small ceramic discs, which is 47 picofarads, 0.001 picofarad, and 470 picofarad in that order from bottom to top. And when I say cascading, obviously these are all in parallel, not series. They are just ordered in cascade because I want to utilize fractal geometry, accounting for the McGinty equation. And so basically it's just two rails, a negative and a positive. And the MEG here is obviously very simple, and if you want to get more information, you can look at TimTron's channel. He has a good video on this. Mine varies a little bit with the core as well. My core is actually this same material. It's one of the sections of one of these C's, and I took one of these ends right here and I just cut it like this. So that's why it's rounded on one side like this. And I duct taped it to keep it from delaminating. And you can kind of see in the cross section right here where I stuck my finger, it's dark, but it's laminated, and that's the cross section. And I just have it butted up against so the magnetic flux goes through. I didn't put any material in there. I just kind of smashed it together. It seemed like the flux was going through better that way for me for this, but maybe I could set it up better somehow different with the dielectric. I'm not sure. Anyways, I took this amp meter and I connected it to here on this ground side with the left prong, and you can see this little black burn mark at the tip right there. Yeah, I made a big arc flash while this was running. It made a big purple flash, and in the center of the purple flash was orange. Now I've had this MEG cell last night doing a green flash on me when I shorted the secondary out with the ground to the ground of this with the quartz, and it flashed out of this third coil through the acrylic into the ground. And that was really interesting because I drained this battery that was just hooked up here. I didn't have the Bendini motor, and the entire battery drained. I checked it on the meter over there, and it was donezo. It had nothing on the reading. I left it hooked up, rehooked it up. Basically, I had this battery over here with these on the negative and the positive terminal. See, that's how I have it like this, so I can just do two chargers in one battery when I switch it back over. And then I'm just adding an extra cap bank over here, and I just leave this on. So I'm just adding to this cap bank over here, and this cap bank is tuned for as a charge controller for that. So I'm not going to worry about overcharging with this, but this cap bank can do some serious discharges, especially when we're pushing very high voltage, definitely way higher than 90 volts past this. And this back EMF is very strong and it's moving a lot of current. I'd like to be able to couple this with the MEG is the intention, and get this center coil to couple with the magnetic flux of this. This magnetic flux goes in an S shape, right? So basically we have it going like this, and then it'll go, or I guess technically it'll do this first with how I wired it, and then it'll go, but whatever, it doesn't really matter. That's the general idea. And so I have to get this monopole structure of the wheel with this longitudinal wave of this core to stack with this flux in timing and push it back and forth. So really I want to rotate this 90 degrees and put it above right here and try to couple this coil with this coil. Okay, talk about this charging circuit a little bit. What's going on here? I got the same diode as over here. Same diode as I use quite a bit, but anyways, it's going to this, which is 4 of these in parallel, and then I got 2 really small 100 capacitors that are like 100 microfarad, and so that way I absorb higher frequency pulses, and I'm trying to pick up like those transient fields and make it usable at this point before it goes into the battery. It doesn't do much, but I figured it's something. And then I basically am using this Zinger diode series to adjust the voltage, and then I'm using this resistor to get the forward current necessary to turn this on, and this drain goes to the positive of this cap bank rail, and the negative obviously goes to this pin. And I have this resistor. I think this is 1000 ohms, and I think this one's like 100 ohms or something. And then this one goes to obviously your load. And so this right one goes down this yellow wire and is obviously connected into that same positive rail, which is going and charging that. And so something to note with this buck converter is that it's operating at 100 to 300 kilohertz. So I'm trying to also utilize these capacitors to pick up those very high frequency oscillations, even though it's technically DC. You know, I'm trying to pick up those oscillations. Nothing's really true DC, infinite waves composed into any given wave. Anyways, let's get this show on the road. I turned it up just a little bit. Okay, so we're gonna turn this on again by just getting it started. Whoa, 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 whoa. Feedback. I'm gonna turn that off. I felt a lot of heat coming off that. Turn that back on so it charges it as it dissipates that. So as you can see, it's still going, and it's turned off. So it oscillates pretty well. That can't come back because of that diode. So K Energy did a good job with this motor. It's not balanced too well. You can see that the 3D print kind of makes this jiggle, and that's what that sound is. So I would recommend in the future maybe just print at a slower speed. And he did a really good job with the print. Like, it's very filled in, and he did a very fine print and did a good job with it. I think there's some room for improvement, like that little seam right there. At these high RPMs, this thing gets up to like 2000 plus RPMs easily. That vibration really is noticeable in this little plastic frame. And you know, maybe we can utilize those vibrations somehow with a piezoelectric, right? Maybe I should put that grounding quartz underneath this and utilize the extra energy of the vibration somehow back into it, but then I'd have to put a diode to filter that energy so it doesn't go into the ground and, you know, make a waveform in the battery I don't want. Yeah, that was the first time I've tried it again. uh, since I was off camera, which is I did not get that bright of a flash earlier. Um, so it's outputting a ton of current, obviously, and this is cold. Let's turn it back on and see if this heats up. I don't want to turn it on for too long because these are for over protection. It's gonna burn itself up if I let it go. It's like a positive feedback loop now. Now I gotta learn how to control it. Um, Not saying this is necessarily over Unity. I don't have all the tools right now to figure it out because I keep frying them all. But I believe that it is at this point, um, from my little test that I've done. So basically, I know that this is producing current now from this, and it's also high voltage from this. And the current from that's coming out of that is much higher than an amp because that flew off the charts and that thing arced pretty far. And I know that that voltage coming off of here is being regulated, but the voltage coming off of there is not from this, but it is from this. So I know the voltage from this is 14.5. So if any voltage is getting higher, it's from the MEG. You see, I isolated it. I isolated this coil, I isolated this coil, and this is coupled to these two things that are isolated, you see, and this is technically isolated too with the diode. And that's why we have these diodes here. And this might even be better with the full bridge rectifier. So that'll be next.